Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A molecule has a non-zero dipole moment when its individual bond dipoles do not cancel due to asymmetry in geometry or constitution. Moving on to the next step. The three CN groups are symmetrically placed at 1, 3, and 5 positions of benzene. By C3V symmetry, all three CCN bond dipoles point outward and cancel vectorially. Net dipole is equal to 0. Moving on to the next step. Analyze option C, CH to Cl, 4, neopentane with 4 CH to Cl groups. The molecule has tetrahedral symmetry, TD. All 4 CH to Cl arms are identical and arranged symmetrically. The dipole moments of all 4 CH to Cl units cancel. Net dipole is equal to 0. And for the final step, piperazine has 2 NH groups at 1, 4 positions. In the chair conformation, the 2 NH bonds can be both equatorial or both axial, giving a centrosymmetric arrangement. The molecule has an inversion center, so the 2 NH dipoles cancel. Net dipole is equal to 0. In the trans isomer, 1 OH is on the wedge, above the ring plane, at C1 and 1 OH is on the dash, below the ring plane, at C3. Although in some cyclic systems trans-disubstitution creates a center of symmetry, cyclobutane is a 4-membered ring. In trans 1,3, cyclobutanediol, C1 and C3 are not related by an inversion center in the same way as in cyclohexane. The ring is planar or nearly so, with OH up at C1 and OH down at C3. The vertical components of the 2 OH dipoles point in opposite directions, cancelling vertically, but the in-plane components also need consideration. However, because the ring is not flat and the 2 OH groups are on opposite faces at non-centrosymmetric positions in a 4-membered ring, the dipole moments do not completely cancel, giving a non-zero net dipole moment. In contrast, the CIS isomer would have both OH groups on the same side and their dipoles would add, but the trans isomer in a cyclobutane, unlike cyclohexane trans 1,4, still has a net dipole because the geometry does not permit complete cancellation. Why other options fail? Options B, C, and D all possess sufficient molecular symmetry, C3V, TD, and Ci respectively, to cause complete cancellation of bond dipoles, resulting in zero net dipole moment. Therefore, the correct answer is A. Therefore, the correct answer is option A.